Hi people. Well, if you have accessed this, then you are directly staring at the Tualumba Secondary School JET forum for Tualumba, and that's basically a science platform which gives you aid in mathematics and other science-related subjects. In this forum, the main aim is just to assist one another with certain concepts. We look at many subjects in the science field, but more biased on physics, and we may go astray and look at some other subjects also, because it is learning, and that's what learning is all about. Okay, your teacher here, Mr. Halube, or the nice ones, and I am ready to start. Today we're just looking at one physics concept under velocity time graph, and in this concept we want to explain certain key terms like rest and constant velocity, as well as acceleration. Then we'll even look at what distance is on a velocity time graph. Okay, so to make my work easier, there is this question I'll work with, then I'll run you nicely so that we can go through together. Then we find out what we need to know as the basics for this learning. Okay, so velocity time graph, what are they? For starters, they are just like graphs, ordinary graph. We are expecting two axes there. Okay, let's just read the question and we start. A vehicle starts from rest. Okay, let me just highlight as I'm reading or follow through. A vehicle starts from rest and reaches a velocity of 30 meters per second in 3 seconds. It travels at a constant velocity for 10 seconds. It retards or retardates in 2 seconds. So I've been given a question which, for most people who've done physics already, they are having a graph in their head. We will do the graph, we'll plot it together nicely so that we see what we need to do. Okay, so I'll work with this, my sketch pad. That's where I will draw and write almost everything for the question. So for starters, we want the axes, the vertical and horizontal axes. I'll draw the best possible way I can, and the fastest, I think this will do it. Okay, so if we had that one, then I erase this other part. Okay, so drawing should be at least neat, especially if you're doing it freehand on a paper. Let it come out neat. Okay, so we have an axis there. Having had this axis, remember the one which is vertical is for the velocity, and the one which is horizontal, this line here, it is for the time. So we first of all show that these lines are continuous, they don't just end, they are continuous. Then we put, for the vertical line, we put velocity, which is v in meters per second. Then for the other line, okay, let me just help you with the clear version of meters per second. Meters per second. Okay, meters per second, I should do it. Then for the time should be in seconds. Time should be in seconds, and that is very important to note. Okay, we have a graph like that one, or the axes rather, the ones we use to make the graph, and we progress. We go back to the question, read it, understand it, so that we see what is needed. So for a start, says a vehicle starts from rest. Now underscore this one, underline the word rest. In physics, when you hear the term rest, it means we are starting from 0, because this vehicle had no speed. That's the meaning. and we define the key term velocity. Velocity is speed in a specified direction, or rather, let me break it down by giving you the actual definition, even comparing that of speed. Velocity is the rate of change in distance with respect to time in a specified direction. So that's, there you go. It's more like just increasing, more like a speed itself moving at some pace. That is velocity. So if it starts from rest, from zero, it means there was actually zero velocity, there was no speed. So it's important to note that our graph will have a zero somewhere there where everything starts from. Then we go to the next part. We lead through the question so that we see what the question offers. So the question says it reaches a velocity of 30 meters in 3 seconds, and that is very important. 30 meters in 3 seconds. If you wanted on the velocity side, you can go 5, 10, 15, 20, 25, 30. But I'll just do it in a shortcut. I'll just put 30 there. So we have 30. Then I'll put the time that we have heard. I've said 3 seconds. So that's our first slot on the time. 3 seconds. So very important. Just that alone is a good start. Now, the next thing you do is you draw a line which should be smooth, and it should find the intersection of this. Okay, let me just show dotted lines so that it actually matches that. When we talk about this velocity of 30 meters per second, it was done in 3 seconds. So yeah, let me help you with dotted lines like that. Okay, so we have dotted lines. If you are doing it freehand, let them be as neat more than I'm doing it. Okay, so we go there. Okay, we have dotted lines to show us that one. Then we get a line now that starts from rest, which is 0 like I explained. Then this line goes smoothly and reaches to the point where we can say our velocity is expected to reach, that is 30. So once we draw that line, we are so far in a good direction towards answering the question. So a vehicle starts from rest, which is 0, and then we have said then it reaches a velocity of 30 meters per second in 3 seconds. So that one is good so far. We go back to the question so we understand more. It travels at a constant velocity for 10 seconds. Now, constant velocity, remember we have defined velocity and speed almost in the same way, only that velocity has got specified direction, but speed lacks a specified direction. Therefore, here when there is this line of increase in velocity, it means there was speed. But when the question says constant velocity, it means we are not expecting an increase in velocity. So time will change, but the velocity will remain the same, or the speed will remain the same. So we are expecting a line which is parallel to the time line, which is horizontal. So, okay, we just want a change in time to what? Let's go back to the question. It says 10 seconds. So we are expecting a change to 10 seconds. If we were to go direct and say 10 seconds there, okay, if we were to go direct and say 10 seconds, just here we say 10 seconds, we would have made a very serious mistake because we have not considered the 3 to have been part of this time. So we should write the number that we have after we add this 3 to this 10, then it will make sense. So we are saying 3 plus 10 should be able to give us 13. So we expect to have a 13 there. So that is how it travels from 3 to 13. There is 10 seconds there. So we now draw a line which is horizontal. Remember, let's just help it with the dots so that our work is, like I said, neat. So we will have dotted lines for the sake of neatness. Okay, there we go. But I expect your work to be more neat than me because I am using this application for drawing. Okay, we try to just be a bit neat. Okay, the dotted lines again. Okay, this is better. So once we have the dotted lines, then we know that somewhere there we introduce a smooth line again, one that goes straight to that point, and it should be very horizontal to the timeline, just like this, like we are doing it. So that is a line representing constant velocity. It travels at constant speed of 30. There is no increase, constant velocity. Okay, then we go back to the question again. The last part says it retards in 2 seconds, and that part is very important. Retards. What is to retard? Now, the word retard in English, it has been used sometimes to describe brain activities. They would say that one is a retard. They mean the thinking capacity goes slow, it goes down. You are running mad, in other words. But in physics, when we say retards, we are looking at slowing down in speed. So this vehicle slows down in speed in 2 seconds. Probably there should have been a part which says and brought to rest or comes to zero. That one is important. Okay, so we are saying it retards in 2 seconds. Okay, for the sake of clarity, let me just say to rest. Okay, brought to rest. Okay, retards in 2 seconds and brought to rest. So, and brought to rest. So it goes back to zero, in other words, so that it's clear. And we have said rest means 0. So when we go back to the graph, we go back to the graph. Okay, we go back to the graph. We are looking at a situation whereby from the velocity of 30 meters per second, it retards or moves slowly up to it comes to the velocity of 0. So now in 2 seconds, so from 13 to, when you add 2 there, we are going to have something like the number 15. So we are expecting a 15 here. 15. Okay, so we can put now the line which shows retardation in 2 seconds, and it should be like that. Okay, so it is brought to rest in 2 seconds. When we have this arrangement, then we have what is called a velocity time graph, and we have done well because it is neat. It explains the question that we were given. Okay, now having done this, it makes your other work easy, and the other work I'm talking about is that of calculating things like acceleration, calculating the distance, just like the other follow-up question which are down here. So we start. Number 1, draw the velocity time graph. Okay, we've done this one. Calculate the acceleration. Now let's go back to the question. At this juncture, you realize that we only have one acceleration. There is from 0 to 30, that is an acceleration. There is increase in speed. Then it moves at a constant velocity. There is no increase in speed. It has not accelerated again, but this one goes down, that is a retardation. So we are calculating only the value of the acceleration. Sometimes it may be phrased in the first 3 seconds. If there was another acceleration, they would say in the second 13 to 15 seconds, just like that, depending on the question. But for our case, the acceleration we have been given is this one. So I remember when I was in class, I gave the formula for acceleration. I will state it once more. I will say acceleration. Okay, we call this question number 1 for the sake of peace, and we call this question number 2. So we say acceleration, okay, yeah, okay, is equals to final velocity minus initial velocity over time taken. Very important. So that is our formula. Acceleration is equals to final velocity minus initial velocity over time. Okay, let's just put the figures there. So acceleration will be equals to, our final velocity reached is this one, 30, when it started from 0. So the 30 is very important. We write it there, 30 meters per second. We say minus. Then our initial velocity, where it started from 0. So that is the initial. Initial is a word which means where we started from under time graph or in velocity. So initial velocity, there we go. It's 0. So we say 0. If you want, you put the units meters per second. Then we are dividing by the time taken, which is 3 seconds for this activity. Then our acceleration will be equals to, okay, we are finding it and it's going to be interesting. So our acceleration is equals to, okay, I'm just making the page bigger. Our acceleration is equals to, we start 30 minus 0 is still 30, and then 3 into 30, that's 10. So we write 10. The units for acceleration are meters per second squared, and that is very important. In physics, if you write an answer without the units, it means the answer is very wrong, because all answers in physics must have units, and units are very important. It's important that we put units to our answers. Let's go to question number 3. I'll write it where it won't confuse us. Okay, I'll put it here. Question number 3. Question number 3 reads as follows. Calculate the retardation. So calculate the retard, the slowing down, in other words. Now, the retardation is referred to as the negative acceleration at some point, and you can interchange the words retardation and negative acceleration. Very important to note. Now, we still use the formula for acceleration. For this one, we say acceleration is equals to final velocity minus initial velocity over time. Then we say acceleration is equals to, what was our final velocity? From 30, where it started from, to the 0 velocity. So the 0 becomes the final there, because that's where it reached. So 0 meters per second minus, it started from 30 there. So we say 30 meters per second. Then we say over the time taken from 13 to 15, it's 2 seconds. Then the value of the acceleration is equals to, or retardation, so 0 minus 30 is negative 30. 2 into negative 30, you have the answer, which is 15 meters. Okay, let me just remove that point. Does not come out well. Okay, good. 15 meters per second squared. Now remember one thing, the negative is maintained there, and it's a very important sign, because it is the only one which differentiates between retardation, which is negative acceleration, and the actual positive acceleration. In physics, those are very serious and good points to note. It's very important. Okay, we have handled that question. Go to question number 4. Question number 4 is just more like a brain teaser. It's just teasing you. Let's look at the question and understand it nicely. It says the acceleration between the 3rd and 13th second. We go back to the graph. This is the 3rd, this is the 13th second, and there is a constant velocity. So the acceleration we are saying it's a change, an increase in speed. Here the acceleration, the velocity was constant. There is no acceleration when velocity is constant. If you want to do the maths, you realize that final velocity minus initial velocity, it will still be 30 minus 30 over maybe 10, the time taken. 30 minus 30 will give you a 0. Then when you divide the 10 into a 0, it gives you an undefined figure mathematically. So that is still wrong. So when there is no increase in velocity, there is no acceleration. Therefore, we just say acceleration for question number 4. Acceleration was equals to 0. Even put the units, meters per second squared. So that is acceleration. We have handled questions 1 up to 4. Okay, we go to the final question, which is question number 5. Find the value of the total distance covered. Now, when we are dealing with distance under velocity time graph, we are simply looking at the area of the figure created by the motion, and this one is a trapezium. If you can apply the formula for finding the area of the trapezium, that same area is the total distance covered. But I'll use the simpler way, though the trapezium way is faster. We go to the way I'm going to use. So we say, where instead of area, we say, this time we say distance. Question number 5. Okay, distance is equals to, this one is a triangle, so we know the formula for the area of the triangle is half, but I will not say BH this time as in base times height. No, this time I will say velocity times time, so I'll say half VT plus the area of this square, which is LB, but I'll replace them with VT, velocity and time, very important, plus the final triangle there, the area of this shape is also half VT. Then let's replace the figures. We are saying the distance is equals to half, the velocity is 30 for this part, that it is, multiplied by the time, which is 3 seconds, plus 30 velocity. Okay, said 30 and written 40 in my head. That's the challenge of writing in the head. Okay, so we are saying 30 multiplied by 10 there, 10. Okay, then the final part plus half again, the velocity is 30 multiplied by, from there to there, it's 2 seconds. Okay, then we have started the mathematics. So we say 2 into 30, it's going to be 15. 15 by 3, that is 45. 2 into 30, yes, we have done the calculation so well. So that is what we find. Okay, thank you. Next, we add again. 30 times 30, we are saying it's 300, or 30 times 10, I mean 300, plus half into 30, that is 15. 15 multiplied by 2, that is 30. Okay, and the total distance will be equals to, we should add those figures, it's very important. Okay, let me use a certain piece of paper. I just add it very fast. If you're faster than me, you can add and tell me the answer, how I wish it worked like that. But now this is a recording. Okay, we are having 375 meters. That is the total distance covered by this vehicle. in this motion. So it's very important to note a distance of and represented by a velocity time graph or speed time graph is just as equivalent as the area of the shape created, and that is physics. Okay, I've enjoyed learning with you. Nason here. It's been wonderful. I hope you've been following nicely and you have understood the concepts clearly, because we should help one another, and that is the life and learning. Remember, be wise and never compromise. Revise to be wise, and otherwise, likewise, you will not rise. All the best once more. Look forward to more videos like this one. Remember, we are doing the sciences and the maths, so I don't know which one I'm going to do next, but it's very important that you just be on the lookout on the same links that you have used. They will come to you. And thank you very much for just being the best listeners to this presentation. Stay very blessed.